Can you see my system now?
Yep.
Okay. My voice is clear also, right?
Right. Yep.
Okay. ZALB_demo. Na? Okay. Just 1 minute. Okay. Great. So this is the presentation. Fine. So these are the few topics which we are going to discuss today. So this debugging, okay. Uh, yeah. So yesterday we discussed few things, but just to reiterate again. So this debugging is a process which is used to identify and resolve the issues, right? And for starting the above debugger, either we can set or use the statement breakpoint. As I said, there are three ways. One is you can put /h on any program, and when you execute it, it will give a full debugging, right? And then there is one more thing where you can put a session breakpoint inside the code, correct? So, so what we will do here is we will start our debugging here. Okay. So when you put here, so you can put the debugger like this. Okay. There is one more way. This ALV demo, right? Okay. So there is some in the utilities, right? In the settings, so you have debugging. So if you can see, I was telling you yesterday, right? There are two types of debugger: classic debugger and new debugger. So in the classic debugger, you are able to see only minimal features like the desktop one, okay, and the standard tables and the fields. But with the new debugger, you have all the desktops like desktop 1, 2, 3, then all these data which I showed you yesterday, right? So now, like if I want to debug once again, so I execute this program. I'll give here any material value like 2454 2246465. So when I execute it, okay. So this desktops, like which I was telling you. So what we will do is we'll go to this desktop 3 where our code and the variable screen will be on the in the parallel, right? So now, as I told you, F5 will be your step-by-step execution, correct? So if I go inside this, like if I put F5, so what it will do is it will go here, form get data, and it will do a step-by-step execution of the select query, and we get the result like this. Okay. Now, if suppose for example I will press F6, so what it will do is it will see if I press F6, see it didn't go to this create fket inside, right? So what it means is this F6 is also like your line by line execution. Okay, it moves to the next line, but it skips any function model, method calls, or subroutines like this performs. Okay, so it will take this as a single line. Okay, so if I put F6, so it didn't go inside the create fket. But say for example, if I want to go to this statement again, okay, and then I press F5. So if you can see here, it will go line by line, correct? Now it is clear, right? For F5 and F6. Okay. So this is how it will go. Then we have this F7. So F7 is like if there is any loop, it comes out of that particular loop from that F7. Okay. So now say for example, let it come here. Okay. So when we come to this display, so if you see this, okay, so if I put F6, what will happen? It will come out of this and directly it will come to this if size is equal to 0. Okay, but say for example, if I want to show you the F7, so you go inside this, since it is a standard program, right? Here also I can show you the usage of the F7. So say for example, I come here, like, let me put the debugger here. We can put a dynamic debugger as well. Okay, let me go inside this. When I press F7, or when I press F7, okay, so the directly the cursor came inside this. Okay, and here, is there any loop statements? Okay, so okay. This is also a very simple program. So I have used also many loops statements in the program that I will show you for F7. Okay. So let me go to something in the pre-demo, or maybe normalization. Is there any loop statement I have used? Okay. So here we will come. So let's see this. So if I go here line by line, correct? So this will be F5. F6, we don't have any function module here, so it will we cannot make use of this one. But say for example, if I want to come out of this F7, this loop, okay, so what it will do is it will run through all the loops and it will come out of that F7 and it will execute it. Okay. So in this, I have not written that write statement, but it is running through that loop 20 times and then it will come out. You remember this program, I have written it for the performance wise, correct? That performance tuning. So generally your F7 will come into picture when you execute the remaining line of the current subroutine function model method and stops at the line after that call, right? So any loop or anything, whenever you want to come out of it, you can make use of the F7. Okay. And if suppose you have like multiple lines, say for example here, say you have multiple lines and you are keeping, like, see the debugger, here we have only three. So let's suppose I keep the your breakpoint here and here. So now when I execute it, okay, and if I want to make use of your F8, okay, so what I can do, F8 is generally for completing, coming out of that particular debugger, or suppose your cursor is here and you want to move to the next debugging point or session breakpoint, then you can put F8. So see, the cursor now came to this perform display. Okay, so that means to move to one your execution, like continues the execution until the next breakpoint or until the program finishes, right? So generally your F8 is either you execute the program, okay, or you can come like, you know, move from one breakpoint to another breakpoint. Okay, so as we step through the program, we can observe the flow of control, check the values like that. Okay, so there are other things as well, like you can put a breakpoint at a subroutine like your get data or a function module. So here I think I have used a like call reuse sorry, what is that? Reuse grid display, correct? So if you have used any function module, So here when you come and you can give your reuse ALB grid display, then in that case when you execute this F8, it will directly take you to that function module. Okay. So similarly, you have this breakpoint at all the things. Like if you have created any exception in your program or any particular source code you want to go or to any particular message, then in that case you can give this breakpoints. Okay. And similarly, say for example, here, okay, you have your 2459. We are not looping anywhere, correct? This one. So this is the dynamic breakpoint we can give. And if I want to display anywhere, or maybe I will have to write a program for showing you a watch point. Like if you want to see, so what the watch point is like, it will stop at a particular field. Yesterday I showed you, right, that SCI message ID number. If you want to display into that SCI, so what it does is it gives an indication of a particular field. It will give the alert for that particular field. Okay. So suppose, for example, if we can set that watch point for a field so that the program is interrupted whenever the value of that field changes. Okay. The display mode contains a list of all the watch points. So whenever you come to this breakpoints or watch points, here, whatever watch points or breakpoints we have kept it, those you can see it in here. Okay. So any program you have done where you have used the loop at field inside your okay, let me do one thing here. Suppose this IT Mara is there, right? What I will do in the sub display, I will write a small piece of code and I'll come out of it to just show you the watch point. Okay, so let's make use of this ALB demo. Okay, in this display, right? So I have my LT Mara, correct? So what I will do is let this be there. So loop at LT Mara into, I will declare a WA Mara is there already. Okay, into WA underscore Mara. Okay, and then I will use write WA underscore Mara, WA underscore Mara, Matner, WA underscore, sorry. You're able to see my screen? It's okay, right? Now?
Yep.
MBRSH, WA underscore Mara, MEINS, and WA underscore Mara, MTAT. Okay. So now what I will do is I will just show you this. This example is just to show you the usage of your watch point. Okay. So let's do this, and yeah, let it be like that. Then what to do? First, let's do this. 252454. So now because you have your LT Mara. where the field values are 2454, 2455, like this. Okay. So what I will do is, I will create 2457. Okay. I will stop the watch point exactly at this point. Okay. So what I will do, Matner, create a watch point. Okay. Where your WA underscore Mara Matner equals to that value. What is the value? Didn't copy. Just 1 second. 2457. Create a watch point. WA underscore Mara Matner equal to. So now your watch point is created. So what it will do? So you can just execute the WR Matner. So can you see this 2457? Okay, it directly came to that point. So it went through this, out of number of line items, it directly came to this 2457. Ideally what happens, it's a sequential loop, correct? But when you create a watch point, so what it does is, what it does is it directly goes to that particular field, and it indicates that okay, we have reached to that particular field. And here you saw one message, right? The watch point has reached. You got this watch point thing? Any doubt in creation of this watch point? Hello?
Yeah. Yeah. No.
Any doubt? See, there are, so what happened in this watch? So if you see now in this breakpoint and watch point, so you can see that there are two session breakpoints I have created, and in watch point there is something called as this 2457. So if you want to change, no, I want to display the item where it is like it reaches to 2464. So similar thing, you can create another watch point and you can give that value to that 2468, and the watch point will stop at that particular thing. So this comes into picture whenever you are facing some issue. Say for example, one of the material value is not coming correctly. Okay, so in that case what you can do is you can create a watch point and see what is the value which is coming in the debugging, and then you can talk with your functional that okay, this is how the values are populated for this particular material number. So either he changes it in the master data, or if there is any correction required from the program side, you can do that. Okay. So this is one way of creating the watch point. And then there is, so I showed you the debuggers like this, correct? So we came here and we executed it. Now say for example, I don't want to create a debugging. So let me delete all the debuggers here. Okay. So what I will do is I will create a breakpoint here. So either you can use a breakpoint like this, okay. Then also what it will do is before the display. So let me execute this. So again, when you come here, okay. So if you see this, it directly the cursor came to that breakpoint statement. There are no other breakpoints. So there are no other breakpoints, so it directly came to this breakpoint statement, correct? So there is one more way also, like if uh, this is the ALV and this is that write statement which I have used, so that's why it is displaying like double times. So now if you want to you don't want to create a, so this breakpoint, right, if you use it, then every time whoever comes to this program, this breakpoint will be like, you know, applicable for all the users. Okay, so you don't want that. So in that case, what you can do is, whatever username you have, okay, so you can use like the breakpoint, or the program should stop for the specific user ID. So in that case, what you have to do is, you have to use this, like my user ID currently is break SRTech 14, correct? So everything will be in caps. Control U will be caps. Okay. Just 1 minute. This is a user specific breakpoint. Okay, so if I want to like either the break username, sorry, you don't have to use this. So if I give this, then what happens is, tomorrow if any other person tries to debug this particular program, this breakpoint will not stop. Okay, so if now I give this will stop for my user ID only. Okay, so that there will be lot of cases where what happens is, for your own like requirement, you want to debug this. Okay, so at that time, what you can do is, you can use this break user ID, which will be specific to your own user ID. Tomorrow if any other users come and try to analyze this program, then for them this debugger will not stop. Okay, so this is another way. And there is the fourth way is, like, let's come out of it. What I will do is, I will use a slash h. Okay, so let's remove this, and I will use a slash h. Let's activate this program. Always remember that the breakpoint will not get triggered in an inactive source code. Okay, so you always have to activate it, and then only your debugger will be like triggered. So if you put here slash h, this is called as a full debugging. Okay, so debugging is vision. This is called as a full debugging. So once you do a execute, so what it will do is, it will go through some 100 to 1000 lines of code. Okay, standard code, and then it will, because lot of GUI sessions and screens and all will have been it will go through that, and then it will come to your program. Maybe, I'm not sure, like after 1000 lines or 2000 lines, like that. Okay, so this is called as a full debugging. This also comes into picture when so if you put like this. Okay, first it came to that ALB screen, and then it came to the ALB display. So generally, why we need this slash h in some cases, some when there is some issue with the standard screens, like say for example, your functional will reach out to you that in VA02 or VA0301, while creating the order, we are getting a error message. Okay, so in that case, what you will do is, you will take that error message. Okay, whatever the error message, in every error message there will be one message class and message ID. So there is one T code called as SE SE91. Okay, SE91. So in this, what you will do is, you will give that particular message class and message number, check what is the message it is coming. Then you do a slash search, and then you create a watch point at message ID and message number. Wherever that error message is coming, it will stop there, and then you can proceed with your debugging. So the next topic is this dialog programming. So ABAP, as you know, we have already seen the report programs, right? Now, what is a dialog program? So I have shown you in SE38, there are, okay, so let me show you in this SE38. So when you create a program here, there are few options here, right? When you say demo 7, okay, if say for example I try to create one, so if you see this, the type, okay, one is the executable program we saw, include pool we saw, function group we saw, right? So then there is something called as module pool. Okay, so this module pool is not a directly executable program. Okay, so if we go to the theory, so these dialog programs are created with type M. Okay, they cannot be executed independently. Generally, we have to create the transaction code for those programs. What is the T code for the transaction code? If I want to create a transaction code for any program, then the T code is SE93. So you can create a particular transaction code, and you can assign the program into that, and then your transaction code will be created. Okay, so let's go to the theory again. So when a user dialog is a form of interaction between the user and the program. Okay, either you can enter a data, choose a menu button, choose a button, double clicking an entry. So all these functions are there. Okay, so this actually generally involves your screens. Okay, because on the screens you have to add your screen elements, assign them names and properties like that. Okay, so this user dialog is any form of interaction between the user and the program. Okay, so dialog programming generally in SAP ABAP, it refers to the development of the interactive user interfaces for SAP applications. So you have seen like IRCTC. Okay, so in IRCTC, what you do, you give your user ID and your password, and then you see the list of the trains, right? So that particular thing is also done in SAP module program. Okay. So in this screen, because it involves the screen development, that's where we use this SE51 screen element screen flow, and the flow logic will be like this. I will show you by creating one program in the module pool, and then you will be able to understand what is the flow logic. So PBO is process before output. That means this is triggered before the screen is displayed. Okay, like how in our report programming, when we are using parameters and select options, and that is a selection screen. So before that, when we put the debugger, it comes to that add selection screen event. Similarly, this is a event for the module pool program where it is a process before output. It gets triggered before the screen is displayed. Okay, it is used to initialize the screen fields. Similar way, like how we have I have shown you the event program where in add selection screen I was initializing that parameters or select options. Okay, then there is another event called as process after input. So this will be triggered after the user enters the data. Okay, you can validate the input, necessary calculation, whatever in this PI. Then there is something called as process on help request. So in SE38 also, whenever we were creating, we were using this F4 helps, right? Similarly, in module pool program also, you have this is triggered like whenever you want to create an help request. This is F1, and process on value request is F4 help. Okay, so these are all the four process flow. And for module pool program, we'll generally use to create it in SE80, and we'll have to create a function module and function group and the flow logic. Okay, so these are some features of the module pool program. You can go through the theory. What I will do is I will straight away go and create a module pool program for you. Okay, so let's go to this SE80. Okay. So I will try to create a module pool program here. Uh, I will. Okay. So this one I will try to use a report to get some Mara details, right? So in that case, um, use it with top include and give z module pull underscore demo. Okay. Z I Mara. Any include name I can give Mara top. So now this module pull program is created. Okay. So now what we will do is first we created this and we gave this type as module pull program. Okay. After that, what we can do is we will create a screen. Okay. So what I can do is leave this part for a simple demo. I'm just using a startup selection here. Okay. This event, and here I'm just calling a screen. Okay. All right. So in this screen, so let's now double click on this particular screen. It doesn't exist. So I will create a screen here. Okay. So this screen is for screen for module pull demo. Okay. So activate it. So this is the flow logic. First, what we will do is we'll go to the layout. We'll design something here. Okay. So now this is how the your screen will display. So what I will do as of now, I will take the table field name like this. Okay. So let's say I will take it as Mara, get from dictionary. Okay. So you see all these fields. So what is my, so what I will do, enter the name of the table, and you can click on this get dictionary, and then all these fields will come up. Okay. So as of now, what I will do, I will click on this Mara Matnar, ERCDA, ER name. Okay. And then you have something called as MTAT, MBRSH, MATL. Okay. So I'll place this here. Okay. So by default, material group. Okay. Industry sector is this thing. Then what I will do is here I will just create a button by clicking on this push button. So there are a lot of fields here. Okay, this is for a text. Okay, this is for input output field. So if you see here, it's a standard. From the standard I have created it. So if you want to create your own custom also, you can create an input field as well. Okay. So as of now, what I will do is I will double click on this and come here, and I will give here, this is a push button. Okay. So the screen, correct. So you can see the push button here, And what we will do is we will give here, say push button name is PB1. Okay, and the text is like get data. So give your get data. So what I will do is I will give the material, and when I press on the get data, the rest of the details should fetch from the Mara. So that is my job here. Okay, and I will give here a function code. What is the function code? FC1. Okay, any other name you can give, PB1, FC1, whatever. Okay, so since it's a function code, I have given here as a function code. So I'll save it and activate it. All right. So now that screen is designed. So what we will do is here in the user command, okay. So we'll try to create a user command here. Okay. So this module pull demo. So here we will write our piece of code. What is that? So generally what happens is your system variable, which so user command is what, like in the events I told you, right? Whenever the if you are create, say for example here we created the push button, correct? So that is a user command. So whenever we are giving any user command means the user will press on something or clicks on something, that means command is come it has been inputted by the user. And generally we'll use the push buttons or for clicking, and for that we will write a specific piece of code. So the standard field which stores the user command is sci-ucom. Okay, so generally here in the module pool program, you can make use of your sci-ucom. So this will capture whatever you click on the push button, this particular field will capture that field value. Okay, so what we will do, we have given the function code as FC1. So in our case, what I will do is I will use when FC1. Okay, in that case, what I will use is I will create select single Matner. So what all fields we took? So instead of using here, what I will use here is perform get data. Okay. Now, let's do in this way. And then there is called as when others, or maybe perform get data. We'll also create a status here. So let it be here when back leave program end case. Okay. So let it be like this. And then we'll go back. So here there is something called as status. Okay. So inside the status, we'll use a set status, and we'll create a z status underscore demo. Okay, I'll double click on this. Status. So now you can see that there are like this status demo. Anyway, so first I created the screen, I designed the layout, and then I gave that material information. Okay, so when I gave the material information, my requirement is whenever I enter the material, the rest of the details should get populated. And this get data or a push button is where my all the logic is inbuilt. So this one is the GUI element which I designed. So if I go back, then it takes me to that program, correct? So it depends on whatever code I have written, right, in this module pool program. So first call screen 100. So I have done that. And then in the user command, I have given that push button function code. So when I press that function code, I will write a perform get data. So inside this, I am fetching the record from that Mara into that Mara method. Okay. And then this BK, I designed it in this status. So this is that GUI element. You can also design rest of the things also, like save and all, but it is based on the requirement. Suppose, for example, if you have designed a custom table and now you want to save some data to that custom table. So in that case, you can make use of this save. So there are a lot of requirements which can come in the module pool program, and based on the requirement, you can design your screen, and then this cannot execute on its own. For that, what you have to do is you have to create your own transaction. So we are done. Actually, we are done. So there is one last thing is the tab strip control. Tab strip control, if you have seen in sales order, right, there are like multiple tabs.
Right.
So through this module pool program also, you can design that tab strip. Okay.
Yeah.
So this is all about your module pool program, and let me know in case if you have any other doubts. Okay.
Sure. Yeah. Thank you.